let's get into the biggest category, energy and atmosphere. 4 prerequisites. Then we get into our commissioning, our retro commissioning. We get into the Energy Star scoring. Remember, we have a prerequisite we have to do first. 75 now, Energy Star score. Some of you might be like, but Charlie, my building took a hit 18 months ago when Energy Star went through some changes. Yep, we have all of our clients in the Northeast all the way over to Chicago. Definitely took a hit on their scoring. You know, they raised the bar. We're going to talk through that. LEED for existing buildings. If you can get an Energy Star score, you have to use Energy Star, pretty much. I'll show you like one exception, 2 exceptions. If you're an office building, you can get an Energy Star score. So that's that minimum energy performance, the second thing on your screen here. But then we're going to get through the rest of the prerequisites. We'll talk about refrigerants some more. And then we keep going down this list. We'll actually talk about advanced energy metering. We'll talk about demand response. We'll talk about renewable energy and carbon offsets. And then we'll cap it off with one more optional point for even better refrigerant management. I don't know if any of you have read the book Drawdown. Paul Hawk and his team did research, the top 100 ways to reverse climate change. And actually, one of the top ways is to make sure we get our refrigerants, buildings and homes under control. And so we've got to do a better job there. All right, so let's start with the prerequisite at the top. For those of you that work in existing buildings, you've probably done an ASHRAE level 1 energy audit before, or hey, let's go in and find ways to still save energy. Okay, so we need to take a look at that here. One of the first things you have to do is you have to have an ASHRAE level 1 energy audit, create an O&M, an operations and maintenance plan. We get all of our run times for our equipment, set points. Hey, how is this building supposed to run? And then we come in and say, hey, where could we still save some energy, okay? Where could we really find no and low cost ways to save energy? We have to have a current facility requirement plan, which means how is this facility supposed to run? And what is supposed to happen in the cafeteria, in the break room, in the restroom? What's the lighting type? What's the lighting levels? And all of that's going to be written out on this plan. Okay, that is one of the requirements here. On LEED for existing building projects, we do have a lot of documentation. So we have that facility maintenance plan. Then we get into our energy audit. We're going to do an ASHRAE level 1 energy audit, which means we've got to come in and find the no and low cost ways to still save energy on your project. Okay. Remember, ASHRAE from your Liedgren Associate study stands for American Society of Heating, Refrigerating, and Air Conditioning Engineers. You're going to come up with this breakdown of how energy is actually used, okay, in your building. And this is an estimated calculation, okay. This is one that you need to take a look at. So we have our lighting, our office equipment, our space cooling, our ventilation, space heating, other. How does our building use energy? Now, if you have sub-meters that really can help break this down, it's going to be more precise. If you don't, what happens is our engineers actually have to take this information. How much energy does your building consume? And then we have to break it down based on equipment and lighting and come up with as close an estimate as we can to how does your building use energy. Now, keep in mind, an office building that has not retrofitted, say, it's T12 lighting, it's old fluorescent lighting. Lighting is the biggest energy hog sometimes on an office building. Here are some adaptations, including a slight tweak for data centers, existing data centers. Next, we're going to move over and get into our minimum energy performance. On a new construction project, we do an energy model, but on an existing building, we're going to take at least 12 months for the consumption. We can go historical, but really you're getting graded on the last 12 months, a rolling 12 months. How energy efficient is our building? As Kelsey mentioned, we need to have our building occupied over 50% occupancy average over the last 12 months. And then we get down into a 75 benchmarking target. Energy Star scoring is case 1. This is most of the buildings, okay? So Energy Star, you're going to get a score from 1 to 100. If you can get at least a 75, you can get your Energy Star label for your building every year. And then you also can now meet the prerequisite for LEED for existing buildings. We have to get to a 75. Now, previous versions of LEED for existing buildings allowed for a 69 minimum score, okay? But now we have to get to a 75. Now, case 2, for projects that are not eligible to get an ENERGY STAR rating, okay? You can either benchmark against other typical buildings or benchmark against historical data and show a certain improvement. Now, if you go this route, you're not going to get as many points as you would with the ENERGY STAR benchmarking. So let me just clear that up. But you can go case 2, option 1. For example, we worked on a big convention center recently. And this project, since you can't get an ENERGY STAR score for convention centers, they were able to compare to other convention centers that they were sharing information, sharing data, and see how they benchmarked against other similar buildings. Or, and it's rare, you could benchmark just against your own historical data and your own improvement. Let's just say you've had a building that was just terrible with energy efficiency, but you know what? You've had a change of heart, you're ready to go for it. You want to save energy, reduce your carbon emissions, make this into a green building. And if there's just no way you're going to get to that 69 or now 75 ENERGY STAR minimum to just meet the prerequisite, there is this kind of case 2 option 2 where you could show a pretty significant amount of energy savings within a certain period of time, usually 2 years in the last 4 to 5 years. That might jump you in to at least be able to play the game, okay? Case 2 option 2. But with case 2 option 1, you can either get data from those other buildings, like I mentioned, the convention centers, or there is some national data that maybe is available. In the case 2 option 2, I just mentioned, so compare site energy data for previous 12 months with data from 3 contiguous years of the previous 5 years. You have to show a 25% improvement over that 3-year period of time, okay? Again, this is rare, but you might need to know it for your exam. Meters are very important. We want to make sure they're calibrated. We want to make sure that, you know, if we're going to have additional sub-meters in place, those are calibrated. How do we use the energy? But at the end of the day, in order to get an ENERGY STAR score, you have to say, here's how large the building is. Here's how many people are in it. Here's where we're located. And here's our total energy consumption. Now, keep in mind, some of my clients in New York City, for example, some of the properties we work on there, you know, they've got not just electricity, but they've got natural gas, they've got steam. You know, there's a lot of different types of energy on a building like that. You know, if they have a backup generator, in some cases, they might have fuel oil. So how much energy does the building consume? And that's what we benchmark based off of, okay? And now we move towards the efficiency conversation. How do we improve those numbers? How do we improve our ENERGY STAR scoring? And here's some strategies there at the bottom right. ENERGY STAR Portfolio Manager, you might get a question on your exam. You know, what do we use that for? Well, we're definitely going to use ENERGY STAR Portfolio Manager for benchmarking our buildings against other buildings in industry, but also against our own buildings within our own portfolio. It's an EPA and Department of Energy tool, the ENERGY STAR Portfolio Manager tool. All right, so now on your exam, you need to know that if we have a 75 ENERGY STAR score, okay, we earn 0 points. But if we get to a 76, we actually start at 3 points. And then every 1 ENERGY STAR point, we get 1 LEED point. So 76 is 3, 77 is 4, going down that list. All the way up to a 95. So if we have a 95 ENERGY STAR score, we're going to meet the prerequisite. We're going to get 20 LEED points, and that's going to help us move up towards gold for sure, and maybe have a shot plaque. The highest Energy Star score my team works on, it's actually a 99. It's legit. We verified it by the book. That means it's in the top 1% of all office buildings in the country. And it's in Washington, D.C. It's 425 I Street. So case one, we get an Energy Star score, we can earn 3 to 20 points. The higher our Energy Star score, the better. But don't forget the prerequisite. You have to at least get to a 75 now under LEED version 4. That's what will be on your exam. Case two, you can get the prerequisite, but you're not climbing the scale and getting those extra points. Now, what kind of building types or space types can get an Energy Star label, an Energy Star score, I should say? Well, here's the different space types we can actually benchmark. But you will focus on office. While you can benchmark medical office, maybe you can't get an official award for that under Energy Star, but any of these space types we can break out and compare to other similar space types and get a score. What is our building from 1 to 1? If we go case two, we can climb the scale. It's a different scale, and I don't think you need to memorize this for your, okay? This is just an FYI. And then case two, option two, 2 to 14 points available, a certain percentage. If you've improved your building by 25% energy consumption off some of your historical stretch there, you get the prerequisite, but you'd have to really improve to go further up the scale. Real life, we're doing Energy Star in most buildings. If it's a unique building type, okay, that starts to kick in over here, okay? And just some pro tips here. Make sure you keep your Energy Star profile up to date. You want to make sure every single month you're updating your consumption, did tenants move in or out, change your space types, change your square footages, your people count, and all that's going to give you a monthly update on your Energy Star score. Next, we'll talk about our prerequisite for building level energy meter. This is similar to the water meters that Kelsey walked us through, or I talked about a little bit as well. How much energy does this one building use? How much water does this one building use? Okay, let's install new. Maybe we already have existing energy meters, sub-meters maybe. Every 5 years, we have to share that information with the U.S. Green Building Council, okay? And we want to make sure we report that out on a monthly basis. Usually, we report that to the USGBC through Energy Star Portfolio Manager. So just make sure how much energy does your building use. You put that information in and you share it with the U.S. Green Building Council. That is a prerequisite, okay? What's the question on the exam? Calibration. You want to calibrate your sub-meters and your meters per manufacturer's recommendations, okay? That's what's important. Next is our Energy and Atmosphere EA credit for advanced energy meter. Next, we're going to get a little more sophisticated here. And we want to take a look at not just sub-metering consumption, but are we going to have smart meters throughout the building? And can we really take a look at some end usage, okay? So these need to be permanently installed. And we're getting into some of the optional credits. This is not a prerequisite. Now we're switching from the what do you have to do to what's a nice to have to get extra points. Permanently installed, record consumption and demand, KW. Make sure that there's a network or wireless. We can store the information for 36 months. And they can report either hour, daily, monthly, or annual usage. The systems would need to trigger an alarm if we're about 5% delta out of a certain predicted range. And we want to consider putting these meters, these smart meters, these advanced energy meters on electricity, natural gas, propane, steam, chilled water, on-site renewables, geothermal. Let's really understand these systems. But we can go further and break it down to HVAC systems, lighting, plug loads, elevators, and other process loads. And don't forget, that'll be on your exam, that 5% variance there, okay? Data centers, as you've seen a couple times, if we have a lead for existing building and we're going for data centers, this definitely is one to take a look at. They're going to slightly modify the scorecard, but we really have to submeter the data centers from the rest of the building. And we even do that on our offices, okay? So on the refrigerant side, let's take a look at our fundamental refrigerant management, okay? No CFC-based refrigerants allowed, but hey, this is an existing building. What do I do with this? Okay, if you have that in your building, you have to have a 5-year capital plan where you show you're going to phase out those refrigerants. You have to make sure that if there were chillers that had CFC-based refrigerant like R11 or R12, that you would actually show a calculation that if we replace those, they would in fact pay for themselves in 10 years or less. If for some reason it took more than 10 years for a simple payback calculation, then they let you keep them, but that's pretty rare. So a couple things on this slide you need to know for your exam. What does LEED consider a simple payback? Sure, it's 10 years or less. And you can see that you have the cost of replacement and conversion over how much energy do we save, maintenance, all of that's going to factor in. That's what you divide it on. So the prerequisite, no CFC refrigerant allowed. And then we're going to make sure if we had that, we have to do our phase out and our conversion. If we do reduce our overall refrigerants from R11 to R12, we're going with better refrigerants. We also need to make sure that we reduce our leakage. This is a number that may show up again in your exam, okay? You can exempt any cooling equipment or even like a water fountain if it's super small and it's 0.5 pounds of refrigerant, okay? 0.5 pounds. The reference standards here are the Clean Air Act. And so I want to make sure everybody remembers from your LEED Green Associate studies that we actually have the Montreal Protocol banned production of certain refrigerants, okay? But the Clean Air Act is our guidance on how to handle the refrigerants and recharge equipment. So the prerequisite, no R11, no R12, no CFC-based refrigerant, we'll phase that out. And that jumps ahead to the optional 1 point. What about enhanced refrigerant management? This kind of feels like a new construction line item. It's very similar. No, what if option 1, we had no refrigerants or low impact refrigerants? We get 1 point. But if we have refrigerants, let's make sure they're less harmful to the environment. We can do a calculation to prove that out. No R11 or R12 is the prerequisite. No R22 or 134 might be acceptable, or 410 is acceptable. Hey, how do we do better with our refrigerant selections? Either no refrigerants, super low impact, or let's go down this chart and find those refrigerants that are actually a little better for the environment. Then we might need to take a look at tenant equipment for this enhanced refrigerant. The fundamental refrigerant is more for base building systems. The enhanced is going to kick in some tenant equipment like some air conditioning and data room. On the retail side, there's a little bit slight tweak. Sometimes in fine print, they have little things like leakage, emission rate. ODP is ozone depletion potential. And then GWP is our global warming potential. The lower of those, the better. Next is some of my favorite credits. We do a lot of this work in some major cities, big buildings, is retro commissioning. Let's get our buildings tuned back up to their best energy saving levels. Let's make sure everything's running the right way. So this is called existing building commissioning. And we start with 2 points for analysis. Option 1 is we can do existing building commissioning, a round of retro commissioning, or we can do an ASHRAE level 2 energy audit. So you actually can go either way there. for the first 2 points. We typically push for the retro commission. So we have an establishment period, everything on the left, and then we're going to go execute that retro commissioning or existing building plan. So we want to make sure we have our proposed schedule. Here's the current operations, but here's kind of when the building was built, how the designers thought it should run. We take a close look at your systems narratives. Some of that came up in our prerequisite, but now we're actually going to send a team out to look at trend data, to really get into the building and make sure it's running at its best settings for today's use. Retro commissioning or existing building commissioning really does 3 main things. Number one, make sure we're saving as much energy as possible. The systems are tuned up and running the right way. Number two is make sure we provide for max comfort for the occupants. You know what? It's running the right way. We can adjust this, but still keep everybody comfortable. And number three is helps equipment last longer. Option one is the retro commissioning round, the investigation. Option two, though, would be maybe we just do that ASHRAE level 2 energy audit, where we're getting into a more detailed audit and looking at that information, that data. That is still a possibility. ASHRAE level 1, ASHRAE level 2. We're still going to reference the ASHRAE guidelines for commercial building energy audits. So the first 2 points are existing building commissioning, and we're going to go ahead and do the investigation. Now the next 2 points are for implementation. This is where we sit down with our report, or sit down with the client, and we really show, look, here's what came up, we think you should plan for. Did you also implement all the no and low cost items that came up in our energy audit? Did you implement the no and low cost items? And so this is something that your team can work with the client and set a threshold. What is considered low cost? Is it $2,000 project, $30,000 project? But LEED would like to see that you acted on the energy audit, which was a prerequisite. And now you actually came in, implemented the no and low cost items, and you're at least considering for your 5-year plan, some of these deep retrofit projects, some of these improvements. How can we really go ahead and save more energy on our building? So this part 2, it's called implementation. It's worth 2 LEED points. And finally is what we call ongoing commissioning. Ongoing commissioning is where we've already tuned up the building, but now we're going to come back out at least every 2 years, but our team likes to come out every year in the heating and then again in the cooling season, and then make sure that the building is not getting too far away from that baseline. So for ongoing commissioning, we actually go ahead and lay out a plan. We're not going to come back and tune up the entire building, but we're going to come back and check this equipment on these floors, you know, and we're going to come back and do some performance verification, some actual systems testing. Are these systems running the way they're supposed to? On your exam, you might need to know what is to be included in a commissioning plan or an ongoing commissioning plan. And that's where this is a good list for you to take notes on. Again, by the book, they say come out at least once every 2 years, 24 months. What we typically do is coming out every year, once during the heating, once during the cooling season, and make sure that the systems are still running the right way. We're not going to let everything get too far off track. This is performance-based, sending teams to the field, not just to look at the trend data, but to really test the equipment, make adjustments with the building operations staff. Next is demand response. This one's pretty fun. LEED version 3 did not have a demand response credit or line item. You could do 1 innovation point if your building did demand response. But here, with LEED version 4, you can actually earn up to 3 points. It's a big deal for us to really move towards a smart grid, for us to move towards that balance with energy consumption between our building and the utility company. So demand response is now worth up to 3 points on lead EV O&M projects. I do think you'll get a question on your exam around that. Now, for those that aren't familiar with demand response, this is a good slide to kind of sum it up. Think of your building or think of your home, and you're familiar with kilowatt hours, right? kWh, kilowatt hours. Well, that's how much electricity you consume in a period of time, right? Your monthly power bill at home, that's how many kilowatt hours you used. How much did you consume? That's your energy efficiency on the left. But on the right side, demand and demand response is actually how fast you consume electricity. And that's called kW, or kilowatts. So on the left is consumption, kilowatt hours. And on the right is kilowatts, kW, and that's your demand, how fast. One simple example I heard someone say one time is picture a chocolate cake. Okay, how much of the cake did you eat? That's kilowatt hours, efficiency. And on the right side, how fast did you eat it? That's kW. On existing buildings, you can earn 1, 2, or 3 points for your demand response program. Demand response, we're coming up on the hottest parts of the year in July, late July in most parts of the United States. We don't want to have brownouts or blackouts, so we need to have what's called grid harmonization. We need to make sure we're really working with the utility company. If our building uses a tremendous amount of energy, typically, can we make sure that we have a relationship with the utility company? And if they need us to, we could use less energy that day or that week when it's the hottest week, or in some places the coldest of the year, so that our building, we really can use less. Well, if you actually have a fully automated DR, demand response program, you can get 3 points. Case 2, the demand response program is not available, but we're going to do curtailment anyway. Or case 3, we can do some permanent load shifting. You can get 2 points. Demand response program is available. Case 1, we have to have a 1-year agreement, and we need to make sure we'd be able to shave 10% of our peak demand. So if an office building in July typically used, I'm just making it up, 100 with kW, well, you know what? You need to be able to run your curtailment program and get that below 90 or below. That way we're taking that burden off of the grid, the power company, and we can avoid those brownouts and blackouts that, fortunately in the United States, knock on wood, we don't get too often, much at all. But overseas, it can happen quite a bit. So that's case 1. But case 2 is, what if we didn't have a demand response program available? Okay. What we could still do is called curtailment. Okay. When we really need to be participating, we're going to shut off some elevator banks, and we're going to adjust the thermostats on these floors. We're going to make sure we close all the blinds. We're going to make sure we send some departments or some tenants home to telework that day or that afternoon. Are there some things we can do that, if needed, we can go ahead and make the building use less energy at that time? And if you do that, the utility companies are going to reward you financially throughout the year for that readiness. Then we have case 3, which is actually called permanent load shift. So what if we maintain or install systems that are capable of shifting load to off-peak on a continuous basis? Can we shift? And then next thing you know, less of a burden on the grid, but not just once a day, one day out of the year. No. What if we can do a permanent shift? You can pick up some extra lead points here. So when you're working with your utility company, you have to ask yourself, are we going to have a manual demand response system where maybe we go in and we shut off some elevator banks and we adjust thermostats, but a lot of that's manual. Can we do semi-automated where we can run a script on our building control system? It's going to put some of that in effect. Or fully automated DR, demand response. That's where we might actually give the utility company access to our building controls, we won't really notice it, but every 15 seconds, they might adjust the fan runtime. And that really helps them not have to produce as much energy to hit the grid. And they'll pay you for it. So again, you have to ask yourself, what we're doing, manual demand response, semi-automated, or fully automated DR? All right, let's go to renewable energy and carbon offsets. We're going to take a look at our energy consumption from the prior year. And we want to make sure that we would offset. We would buy an offset, usually renewable energy credits, for a 2-year offset. We need to make sure that if we're going to buy green power offsets, they're Green E certified, okay? Now, if you have natural gas, some steam, we have to buy carbon offsets. But most of the time when we're offsetting other energy, especially electricity, we can go straight to Green E certified. We like to buy, say, from wind farms in Colorado. Now we get into some of our emissions that we have to offset. We have scope 1 and scope 2 emissions. And this is good for some of you that are newer to carbon disclosures. Scope 1 emissions are greenhouse gases, GHG, that are emitted directly from sources that are owned or controlled by the entity, burned on site, versus scope 2 emissions, which are associated with the purchase of like electricity or district chilled water, steam, hot water, etc. RECs and carbon offsets, you can see they have different ways we offset. So RECs can only be used to mitigate scope 2. Carbon offsets can be helped with scope 1 or scope 2. Let's sum that up. Scope 1 emissions, think, maybe we have natural gas that is actually used on site to create, maybe a fuel cell. So we're taking the natural gas and we're converting it to electricity. So that's going to push us to the scope 1 emissions. Maybe we have a fuel tank as backup for a generator. Okay, that's on site. That's scope 1 emissions. But scope 2 emissions are, I'm in the state of Georgia. Fortunately, Georgia's doing better. We have a pretty good mix of biofuels, solar farms, but we still have coal-fired power plants. And so scope 2 emissions would be all those power production facilities sending electricity to our building, scope 2. And there's the calculation at the bottom. These are the systems that are eligible, okay, for renewable offsets: photovoltaic, wind, solar thermal, biofuels, geothermal, low impact hydro. The fish can still swim upstream. And then wave and tidal if you're on the coast. What doesn't count here, but could show up in other parts of LEED based on efficiency, would be architectural features, passive solar, daylighting, and geo exchange systems. All of those are going to help us get a higher Energy Star score. Okay. But they count for efficiency and they don't count here for renewables. And you can put renewables on your site, or you can buy the offsets off-site for some of these LEED for existing building credits. And that's the calculation here. What do we have on site versus what might we do with offsets? Now here's a little bit more information about your direct and indirect emissions. And again, that's the main difference. Direct, or that kind of scope 1, is burned at the building, versus indirect, or scope 2, is the energy from our utilities. Here's how we're going to calculate your greenhouse gas emissions, or your metric tons of CO2. And we have to put an emissions factor on it. For example, in New York City, they have a new law came out last year, Local Law 97. And buildings have to not just disclose how much energy they use, transparency, they have to do some retro commissioning and energy audits action. but now they have to make sure that they're below certain carbon caps for their buildings by 2024 and then 2029, 2030. So you have to apply these emissions factors. So if you use 1,000, what's a good example? Gallons of diesel for your backup generator, you're going to come in here and use that 73.15 coefficient to help calculate your emissions. And so you might want to ask yourself, as you're going for LEED or even on a project that's non-LEED, do you have some offset goals? It's a great corporate sustainability stance. Definitely helps you get extra LEED points, okay? And what is green power? Make sure we're going to buy some green power, maybe pay a little bit extra per kilowatt hour per month, or we can do the green power offsets and buy the renewable energy credits, but don't forget they need to be Green E certified, wind farms, solar farms, etc. As we start to wrap up this energy category, we have to think about synergies. If I do this on my LEED project, what else will it affect? So we have our EA credit prerequisite for commissioning. And so what we're trying to say here is, as we change out our systems, HVAC systems, lighting, to help meet the energy efficiency mandates, well, that needs to be tuned up. It needs to be commissioned. As we reduce our light pollution, we need to make sure that we know that's going to save us energy. As we come in and do our indoor environmental quality and our air quality, well, that could affect our energy savings. So all these are different synergies that show up on your projects. And remember, synergies like, if I do this, what else will it affect on my project, good or bad? Here's a couple more. Don't forget about your water efficiency. Let's say we have a water efficient shower head, and therefore we're going to save water. Well, don't forget you also save some energy. We're pumping less water or heating or cooling less water. So that's a synergy. And finally, refrigerants. We want to go to the man-made refrigerants that are better for the environment, but also still energy efficient if at all possible.